In this video, I want to talk about the principle of superposition. So we've been discussing some interesting uh, um, results of quantum theory. And so one of the most interesting ones is superposition. The fact that I can write a state, call it psi, as the superposition of two eigenvectors, which I've labeled as lower omega 1 and omega 2. Now, alpha and beta are just factors which give the strength to each eigenvector. So, alpha and beta could be 50-50, or it could be alpha's, has a strength of 70%, and beta has a strength of 30%. These are the factors that we're going to use when we are going to be trying to figure out the probability density of a certain observation. And so I can now, if you remember that we have to normalize each state. And so the normalization we're going to get from taking the state and then dividing it by the norm. And this is to the 1/2 power. And so in this case, our normalized state, psi, would be alpha times the first eigenvector plus beta times the second eigenvector divided by the norm, which in this case would be alpha squared plus beta squared to the 1/2 power, like so. Okay, so this is our normalized vector. And so then what happens is we could, say, operate on this with an operator I'll call omega sub alpha, where in this case this operator chooses the first eigen state, which in this case would be alpha omega 1 divided by the normalization. And we don't get beta because omega sub alpha acting on omega 2 gives me a 0. Or I could operate with a different operator that selects the second state. So in this case, it would be beta times omega 2 divided by the normalization, like so. And so in the end, what we get is this connection we have, or kind of a mathematical way of writing down the statement that the operator chooses the specific outcome of the measurement. So in this case, there were two possible results. We could either end up in state omega 1 or state omega 2. And then when we apply those operators, the operators then choose them. So if I'm a theorist trying to calculate what is the most likely outcome of some measurement, I know that the two possible outcomes in this case are omega 1 and omega 2, and then I operate on it and I say, am I going to select either the omega 1 state or the omega 2 state? I'm not going to select both of them at the same time. They're two independent results. But by choosing the operator which selects the omega 1 state, I can come up with the fact that the result is going to be alpha divided by the normalization, or if it's state 2, it would be beta divided by the normalization. And that eventually is going to lead to our calculation of the probability of that result occurring in a measurement. Okay. So in in the end, what we have is the different possibilities. Before we do the measurement, there are many possibilities to the measurement. When we make the measurement, then one of the possibilities comes out, and the probability that that outcome is going to occur depends on basically the strength of the state, the strength of what it is. So in the end, we could have, let's say if I had another variable, not omega, but another variable lambda, and I apply lambda to our state psi, and then it gives us some, eigenvalue lambda sub I times the state lambda sub I. The probability that I'm going to get this result, the probability density, is basically projecting that particular result onto the total initial state, and then it's squared. Where again, this is normalized. So really what I'm saying in words is what we're eventually going to get to when we start applying to problems like the harmonic oscillator or the hydrogen atom. Hopefully all this mathematical machinery will make sense, and so these descriptions of what we're doing, these explanations with words, will make sense when we get there. So finally, what I wanted to say is that so I can try and solve these problems in different bases. And so if I have two bases, two basis states, one which I can access through omega, another which I can access through lambda, then physics wouldn't really help us if there wouldn't be some sort of communication or be able to translate from one basis state to the next. And so if we end up projecting lambda onto our state psi, I could rewrite this as lambda projected onto the state omega, and then the state omega projected onto the total state psi. Because this is possible because we said the identity was the sum of all possibilities of omega. So we've seen that before, that we want to change from one basis state to the next. It'll become clear once we start working on actual physical problems, and and stop talking about things just as abstract mathematical constructs. And then we'll start showing how you can start in Cartesian coordinates and then move into something more like spherical coordinates.